Hello, class. So you haven't heard me do a lot of videos because Cindy does like all the, sorry, Professor Arnold does all the videos. Uh, but I know that from previous experience, I know doing the haikus this can be kind of daunting. So um, I just want to talk about a couple things. I might need to pause because I just realized I didn't do the second part that I wanted, but that's like an editing thing you don't need to know about. And as you can tell, Professor Arnold and I have very different styles when we do these. Hers are very thorough and concise and clear and scripted. I can't do that. I can't do scripts. I have to talk off the cuff and like go where my thoughts take me. So uh, you get a little bit of counterpoints there, different styles. Anyway, so what I've done, I just want to go over a couple of tips that I think are the heart of understanding how to do the haikus. So I'm just going to show you. It's almost giving it away a little bit, so pay close attention. I'm not going to show you exactly how to do it for the haikus, but what I show you here should be able to be applied to the haiku. It's lab 3 again. I keep calling it, I think of it as the haikus lab. But anyway, so these are C-type strings. These are the strings that I learned. Like, you guys have it easy with the string class. Now that's a different string. That string data type that you have available to you is a lot easier to work with. This is what I had to work with when I learned, because I learned C first. So to me, I'm basically working in C right now. So there's two things here. First of all, your haikus are going to be this. It's going to be your haikus are going to be stored in a two-dimensional character array. So it's going to be, I'm just going to try to describe this now before I get to it later because I don't have the example for it yet. But slide editor. But what you want to envision with this, imagine this is your haiku. So your haikus are going to be stored in this two-dimensional character array, right? What you want to imagine with an array declared like this, now you'll have different numbers. You'll probably have variables or constants right here, like for the number of lines in your haiku. So your haikus are 3 lines each, right? So for 10 haikus, you would need 30 lines. So I call it lines here to make this clear. When you have a 2D array of C-type strings, just think of it as, and of course C-type strings don't have to be single words. They could be a whole line of text. So another clue about what you need to do in this lab is look into the getLine function as opposed to CN or scanf or any of that. For input, look in how getLine works. It should go to the end of a line where there's a new line character. So you'll have like a whole sentence maybe, or a line of haiku in this case, several different words, but on one line. So I want you to envision this 2D array. That first number is how many lines you have. Don't think of it as a 2D array of characters, like at that level of granularity. Don't think, okay, I need to go down 3 and then go over 3 or 4 or whatever. Don't think of it as like a grid of characters. Think of it as lines of haikus. So each line, in this case, there's 10 lines, right? 0 through 9. And then you have up to 40 characters. Why 40? Because the size is 41, right? That can have 41 characters. Well, it does technically have 41 characters. Actually, it might have more for the new line. I have to think about that. No, actually, if you store it here, you don't have to store the new line. But it's the end of line. It's the end of string character. There's the null character. ASCII 0. Double quotes \0. That's that special character. When you're working with C-type strings, you always have to leave one more character than you think you need to accommodate that null terminator. That's another word for it. It's how the string library understands that the array of characters that you have is a string. The definition of a C-type string, and Professor Arnold might have put it this way, I'm not sure if she did or not, but it's just a simple array of characters. You have an array of integers, array of double, array of anything, right? This is just an array of characters. The only thing that really makes it a string is that it has that null terminating character at the end to show where the string ends, because that's how the string library knows where to stop. It's like the brakes, it's the stoplight. If you take that out and then start working with the string library, you'll get a big mess. Try it sometime. You get a big mess. So like, make an array just big enough of characters not to have the null terminating character at the end. Specify the characters that don't even use the input functions, like scanf or cin or whatever. Just define, like, you say you have 5 characters, and so it would be 0, 1, 2, 3, 4, and number 4 is not the null terminating character, and then just do C out, print it out, or better yet, use the C type C string things like printf. Say printf percent what would it be for array of characters? Percent s, comma, and then the array. And what you'll get is you'll get the first letters, the first 5 or 4. Yeah, it was 5. I said right. First 5 letters, first 5 characters, and then you'll get a bunch of junk until it gets to the null. By chance, it might get to the equivalent of ASCII 0 or the null terminating character, and it'll stop there. But you'll get a bunch of garbage. So again, there's a slight edit there, but the main thing I want you to keep in mind when you're talking about the two-dimensional array of haikus is that each line in the haiku will be accommodated by this number. So, for instance, if you had 3 haikus, this would have to be 9, right? So the first line of the first haiku would be line sub 0, or haiku sub 0, if you're using haikus as the name of your 2D array, which I recommend. Line 2 would be haikus sub 1. And then, like, think of this as how long your line is. So you have to make sure it's long enough to accommodate like an entire line of a haiku. I think there's a maximum size that's specified in the lab. That's the kind of stuff you can go back and look at Professor Arnold's video. She specifies all that. But again, this is the length of the line, the second number. And the first number is the number of lines. Think of it that way. And it's easier to understand how to work with it. Okay, so the rest of this example is not 2D arrays. It's just working with strings that are individually, because at some point you will be working with, for example, if you want to read the whole first line and like mess with it, then lines sub 0, for instance, you can work with that as if it's a string. So you have your first line of your haiku, you want to manipulate it. Instead of being like just line or whatever, just, you see how I have char word here, and it's a single dimensional array. You can work with the haiku sub 0, haiku sub 1, or whatever, as if it were a single dimensional array. That's the other part. This is kind of attached back to the whole 2D array thing I'm trying to explain here. In other words, I'll show an example since I don't work with this. So open up a line and stir copy. Let's say I want the first line of this 2D array to be, I don't know why I think of 7 years ago. I think it's 2 words. Is it 1? I can't remember if it's 1 or 2 words. I'm sorry. I'm getting ahead of myself here. I want to read into the first line this phrase. Just make sure. I know that's not 41, but I definitely don't want to go over it. Okay, so then we're going to print out this line. So we'll just do C out. So line sub 0. Now, if you're actually working, of course, with these, you're not going to use hard numbers. Probably you're going to have variable like an I or something there, right? Instead of a 0, because you're working with it in a loop. Because you've got more than one line in your haiku, and you've got more than one haiku, so you'll have to like work with it over a range. So you're going to probably be using variables. And by the way, I don't know if I brought this window up yet, but I recommend like having another connection terminal to the same directory, so you can just do this instead of having to go in and out of your of your editor. So I'm using VI, by the way. I'm not using Nano, but I'm sure you all can follow along. So you see how the first line, this is for something later, but see how this first line printed out 7. So it did that because that line sub 0 is the first line. So see how you can work with, if you got a 2D array of C-type strings, you can work with each line, think of this as rows, right? Lines down the screen as if it were a single string if you use this index here. So that's the only difference between this and this. This is just a single one-dimensional array. This is a two-dimensional array. But the way you work with them is if you're working with a two-dimensional array, you just have to add the row that you're on, the line you're on. And that line, think of each individual line in your 2D array as ending with a null terminating character. And then you can see it's kind of almost, it's a 2D array of characters technically as far as the computer's concerned, but logically for the human brain, it's a 1D array of lines. That's how you want to think of it. Trust me on this. It might sound confusing at first, but once you understand that, the whole haikus reading into it makes a lot of sense. It's the combination of the null terminating character at the end of each line, plus realizing that each line is kind of like a single string. So you have a bunch of strings going from first line of your haiku to in the first line of the first haiku to the last line of the last haiku. All right, the other little tricks I need to show you, and when I just ran that, it didn't seem to be working right. Oh yeah. This is the old version. It shouldn't be couting word here. It should be, hold on. Yeah, it should be couting new word. I made that change. Hold on. New word. It's a little too enthusiastic about my semicolon there. All right. Yeah, that's good. That's what the right answer is. So let me show you the second part here. This is the other thing. Now, the first part, again, just to summarize that, is conceptualizing it as a bunch of lines that are single strings, C strings, a bunch of lines of them. So instead of lines, you probably have haikus, and then instead of the word lines here, you would have haikus. Instead of this hard-coded 0, you probably have like a variable like I or line or whatever. The second part is down inside when you're working with each line, and maybe I should have shown you all in one with a 2D array instead of doing a separate single-dimensional array of a single string called word. And I usually put a 1 at the end. Say if I want to say I have 11 or whatever, if it's a string, I usually put a 1 in just to remind myself that I have to make room for the null terminating character. You don't have to put a 1 there, an odd number, but I like to do that just to symbolize it. So that's a little trick too. And again, you should probably have constants declared inside of your haikus at the end of the day and not be using actual magic hard-coded numbers like 11 and 31, but regardless, you get the idea. Okay, so what I've done here so far is, this is kind of like saying CN Caldera. So CN, well, it's not CN. It's not the same as CN. Let's say you have a string called word. It's like saying word gets Caldera is what the equivalent is here. But you can't do that in C with C-type strings because word is an array of characters, and you can't have it. It just doesn't make. It's hard to explain, but it doesn't make any sense. When you do the lab for Lab 8, which you should be working on right now if you haven't done it yet, you have to write your own version of stir copy, and you can't use stir copy. You can't use anything in the C string library. You have to do it yourself. You have to like use a loop and stuff. So you need to copy each letter one at a time from one C-type string array, character array, to the other character array. Right? So the one you're copying to should start out empty. Basically, it's going to contain one character, which it should be. The character it should contain is like the null character, or you don't even have to do it that way. Actually, it can just be an empty string, and it doesn't matter what the first character is. And you copy each character of the second string into the first string one at a time at the same indices, right? So 0 of the second's copied into 0 of the first, and so on. That's a little bit of tip for your lab that you might not know, your programming exercise you might not have done yet too. So have a variable that's going from 0 to the length of the string that you're copying, and copy each character into the first string, the first array, character array, at the same index. Make sure the first character array is big enough to accommodate everything in the second, the thing you're copying from. including the null terminating character. Don't forget that. Okay. So I'm stir copying Caldera into Word. Let's get back to this. And then I'm stir copying Word into New Word. And the reason why I'm doing this right here, if you compare this to what you have to do with the haikus, is a similar thing, because you'll have a list of substitute words to stick in for the asterisks. And pay attention how you say that word, by the way. It's my little pet peeve. If you don't say asterisk, you risk sounding silly. That's I just made that up. But it's all right. It's like risk at the word. It's not Rick and it's not Ricks. It's risk. Anyway, it means little star, I think, in Greek. So you can say star. It's perfectly acceptable in the computing programming world to say star for asterisk. But, if you do say asterisk, please say asterisk. You can have several asterisks, and it gets hard to say, but whatever. Okay, back to where we were talking. So what I'm doing is, because what you'll have is you'll copy like the substitute. You'll copy the haiku into your line, or whatever your line. You'll copy the haiku line into your 2D array, I think, is what's really going to be going on. So word kind of represents like a line in your 2D array. And then actually that might be this. That's what you're doing here. You're copying some line into your 2D array. Then you'll have to find where the star is. So instead of the star, I made it an E. The word caldera, by the way, I just had a YouTube video when I was about to start this, and somebody was talking about loving natural parks and how the whole west of the United States might be a big smoldering caldera at some point because of the, imminent explosion there. Eruption, that's the word. Who knows when? Maybe not anytime soon, but maybe. Anyway, in my haikus lab, I have a function called find asterisk index or something like that. So what you want to be doing is and take some tips from your programming exercise that you do, like when you do the stir copy and stuff. Maybe, I know there's a stir copy part to that. There might be regardless, the stir copy is good enough. Like going letter by letter and then returning at a certain point. Is what we're doing here. Might actually be Sterling. I can't remember. But anyway, so what you want to do is find where the asterisk go. In this case, find where the E is. I'm looking for the E in Caldera, because what I'm going to do, what this little code snippet's doing, is it's going to find that E and it's going to skip over. It's going to insert something in place of the E. So you'll have called, some other gibberish, and then you'll have ruh. This kind of is the same thing you'll be doing with your haikus. You'll have the first part of the haiku, then you'll substitute in a word for the asterisk, and then you'll have the rest of that first line of the haiku, depending on where the asterisk is. If it's at the end, it doesn't really matter too much, but if it's at the beginning, it matters. If it's in the middle, it matters. So if you do the same thing for each one, the same process of like finding where the asterisk is, inserting the new substitute in there, like the funny word that the person makes up to insert, like the Mad Libs word, right? The fill in the blank. Think of the star as the fill in the blank. In my example here, the E, the highlighted thing there, is the fill in the blank. The E is going to be erased. We'll have called, and we'll have something after what I insert, but we won't have the E anymore. We'll have the ruh after. So this finds the last index. So this is the function. You'll have something like it won't be exactly like this, but it'll be very similar. It'll be the same logic in your program. There's other ways you can do it maybe, but this is the way. I can't think of them right now. This is the way I did it. So what I do is I just start off my loop iteration variable, like for int I equals 0, that kind of I, except I'm using a while loop here. I could probably convert this to a for loop, but to my brain it makes more sense as a while loop, because it is kind of a sentinel value thing, right? The human being at least doesn't know how many characters there are before you get to the end of the word, the end of the string, the null termination character. So that's why I made it a while loop. Anyway, so just make it equal to 0 because we're going to look at each character in the word, starting with the first character one by one. So we have to look at word sub 0. Now this word here, I could have called this food, blah blah, whatever. I just called it word because my brain says word. It's not the same word as the word above. And if I could do refactoring in VI, I would just do that. I probably can actually. I just don't know how to do it in VI. But I don't want to have to change all the instances of it. But just keep in mind, this is a parameter for this function. It only has meaning here. And what it will have is they'll have the address of the first character in whatever string you pass, each string array of characters you pass to it. So again, it's not the same as the word above in main. It's a different word, but it might be the same word though. It depends on what you pass to it. I think, what do we pass to it actually? New word. We pass new word to word. So this is actually new word right here. I know that's confusing. I'm sorry, but that's just how things work. And then this E index is something I don't use. So let's get rid of that. I was using it before when I didn't have it as a function. So what I do is, as long as the character that I just looked at, in other words, as long as word sub 0 is not the null terminating character, in other words, we have an empty string, right? As long as it's not that, then what I do is check to see if it's E. If it's not the null character, which means we need to stop, I'll check to see if it's the E. And if it is the E, I just return that index. Otherwise, I look at the next character. And technically, at the bottom, I have return I here. At the bottom here, I should have like some kind of indicator that I didn't find it in your code. I think you'll have a constant that you return called malformed, I think, or maybe I made that word up for my lab. But malformed means that you didn't have an asterisk. You should always have an asterisk. If you don't have the asterisk in your sample in your haikus, then somebody submitted an invalid haiku, right? So you need to report that, hey, I couldn't find a star in one of the lines, and there needs to be a star for this program to work. In my example, that's not really what's going on. There is an E in Caldera, so I'll never get the -1. But you should have this at the end, like, I didn't find, there is no E in this, so return -1. But in this case, it will return the index where the E is, which is what? 0, 1, 2, 3, 4. So it'll return 4. So when it does that, it assigns it to this variable called E index. And then what I do, here's the key, I make in the new word. So again, this is you copying into your 2D array, because when you're done, your 2D array of haiku should not have asterisks. It should have the substitutions in there. So line by line in your 2D array, you need to substitute in the funny words, the Mad Libs, into the stars. This is kind of what I'm doing here. And the way I do it is I go up as far as the star, or the E in this case, but I substitute in for the star or the E, the null terminating character. Why do I do that? Because how does stircat work? Stircat will copy, starting at the null terminating character of an array of characters, C-type string. Right, every C-type string ends in a null terminating character. So what I've done is I've converted Caldera to called, C-A-L-D. But how did I do that? I've substituted it in at that index null terminating character. Technically speaking, new word, what it has in it is C-A-L-D, null terminating character, R-A, null terminating character. But everything after the first null terminating character, the /0, doesn't matter. So as far as the C library, the C string library is concerned, that string's value now is called. The ERA null terminating character doesn't matter. It's ignored because you stop at the first null terminating character, so called. And what does this mean? That means I'm going to tack on some nonsense onto called. And the way stircat works is it takes that S in the second string and puts it where the null terminating character is in the first string. So it'll be C-A-L-D. Null terminating character will be covered up by an S, and then some space nonsense. And then whenever you have double quotes like that and you're doing stircat, it will automatically for you put a null terminating character at the end of that second thing. So you'll end up new word after this line that I'm on right here executes will be called some nonsense. Okay, that's the first key. So what I should do is show you here just a new word. At this point, it should be called a new some nonsense, all kind of run together. Might be prettier as an example if I had like put some spaces and stuff in here too, but it might also have been more confusing. Who knows? So you see, called some nonsense. That's the one. That's this C out right here. This C out right here is this line right here, and you see where we're going right down here. But this is where we're at right now. So the next key thing is to understand this. And this is going to get, if I'm going to try to explain this, it's going to be hard. So you see how we use word and new word all throughout here? Let me show you a different way we could have done this, actually. Whenever I try to change things around, and this just occurred to me to show this example, but something gets messed up. New word, any character array name stands for something, and this is what it stands for. The value that it holds, in other words, is the address of the first index in that array. That's true for all arrays. The name of the array itself, like you have an array of integers called numbers, the value of numbers, that variable, because it is a variable, right? Numbers is a variable, is the address of number sub 0. The address of number sub 0 is what numbers contains, because it needs to know where in other words, it's the memory address of the start of the array. So I could have done the same thing here, a lot more long-winded, and you would never do this. In this case, you would never do like ampersand new word sub 0, which is what the address, that's how you say the address of the first array, if you wanted. The first index, the first character in the array in this case. That's just another way of saying it. So you see how it's still called some nonsense? It's because doing this, what I just did, is the equivalent of doing, and I just said all this more long-winded, but it's the equivalent of just putting new word here, because again, new word is the same as the ampersand new word sub 0. So once you understand that, you can see that you can shift, and I'll put, this is air quotes, you can shift the beginning of the array of characters to somewhere else in the array by what? Specifying the address of some other character. So what I'm doing is, remember we want to insert, so for you, in the case of what you'll be working with, you'll have your haiku line, right? You'll have your haiku where you're copying from into your 2D array, which has all the answers with the substitutions, but you'll have a source like file that you've read in. Maybe it's in a separate 2D array and you're reading it line by line. But what you've done is you've copied the first part and then you substituted in where the star is a word, and now you need to get the rest of that line. How do you get the rest of the line? In this case, I'm getting the RA that I cut off before in Caldera. Where is that located? It's located at word of the E index, wherever, which is 4 plus 1. So 5. The R is at 5, right? In this case. So when you're doing your haikus, you find out where the star is, and then you tack on the rest of the line of the haiku starting at the index after the star. And how do you do that? You're copying this string. What is this string? It's this string. It's you're skipping over Caldera. I'm sorry. You're skipping over called E and then starting at RA. I can't really say this any different way. I think just like understand that this is the address of word sub 5 in this particular instance, because the value of E index in my example is 4. It could be 3 in yours. It could be 10. Who knows? But it'll. And again, instead of E index, you can think of it as star index. So find out which index that star is in. Put a null terminating character there. Stircat the silly word, the Mad Lib word, in at that point after onto your line that you're building. You're building each line of the haiku. So you you copy the first, you can copy the whole line really, but then you want to insert a null terminating character in where the asterisk is. Then after you've done that, you want to stircat the rest of the line that got obliterated by the null terminating character being inserted there. You want to stircat in the rest of the line. So you need to go to the original source where the star was, go one character over, which is ampersand, whatever you're copying from, array name, sub, star index plus 1. And that stircat's on the rest of that. So, and then so you'll see in the end, new word again, this is going to be the haiku you're building. That's how you can compare it to my example. And G++, make sure it's still working, and run it. It's the second one. So you see I have called. This is where the star or the E, in my case is the E, right? This is where the E was. And then I tack on RA, the rest of that haiku. Again, this is going to be for the original thing that you're copying from. It's 0, 1, 2, 3, 4, 5, 6. I hope this helps. If not, come to office hours, you guys. Like, the people who come to office hours are doing really well. So if you're confused, I can't really help you if you don't reach out to me. So, and reach out to me with specific stuff, like, hey, I'm stuck on this part, and as I help you work through specific things, everything becomes easier. I hope, and watch this video. You're not going to hear this if you don't watch it, but still watch all of Cindy's, Professor Arnold's videos, and watch anything, especially watch anything I put up. And I'll say that, I can't say especially, because you really need to watch all of hers to cover all the groundwork, right? But if I make a video, it's because I think you need special attention on certain things. So I'm calling attention to certain things and giving you hints. Aside from this, I should be grading the stuff you turned in last Wednesday, like today or tomorrow. And then keep in mind your lab is due on this Wednesday. I keep calling it lab, but it's a programming exercise 8, I think, is due this week. Start looking at exam 2 stuff. I think there should be. If there's not, I'll make sure. I'll look and see if there is one. I think there is one, an example exam for the second half of the final, right? Make sure you start looking at that, and I'll let you know what you need to know soon about preparing for the final. I mean, it's not too long away, and I don't know who's beeping me now. Nobody ever talks to me on the phone, so whatever. If you have any questions, let me know. This will be up on YouTube. Terminate this video.